Hi, this is Paul again. I've decided to have a good try on this video to see if I can figure out the geometry for the molecules of DNA. I started out hoping to get everything on one video, so I've decided to split them into two videos. So this video will show everything I've come up with for the bDNA. I show in front a yellow cube outline, that's a size 6. And on the left I show 6 Plato cubes. And in the center you see there's a size 5, and these are all Bucky cubes. I show more about this cubic system in my earlier videos, CubicWonder. It is a system that I discovered 5 years ago that gives a perfect order in 3 dimensions. I like these 3D shapes because it's a lot easier for me than doing sums. Okay, what I'm going to do now is run 5 Plato cubes along the top up to the apex. So we'll take all them Bucky cubes away and we'll leave a size 5 cube outline. So now we'll leave the Plato cube on the top apex, and then we'll run a diagonal of Bucky cubes and Plato cubes. As you can see, we have a Plato size 6, and this will drop down to a Bucky size 5. The Bucky 5 will drop down to a Plato 4. The Plato 4 will drop down to a Bucky size 3. Then it'll go to a Plato size 2, and then she ends up with a single Bucky in the center. But the Bucky doesn't have to be used in the center. In front I show a size 4 outline cube. Now we'll scale it down to size 3. We'll move this size 3 up, and we'll show 3 Plato cubes inside the cube. And this can give us 2 Buckies. And we also can do the same in the opposite direction. I think you're going to find that this is a very important feature for DNA. Let's take another look at this feature. We'll start with the cube on its own, and then we'll bring in 2 rings. This ring I call the Yucatan ring because it was a latitude of 20.9. We'll bring in the dodeca, and you can see these rings. We'll call the 2 rings Yucatan rings. We'll go back to the outline again, and then we'll bring in 3 Plato cubes. Now you can see that the 3 Plato cubes are split into 3 sections. The sections line up with the Yucatan rings, and this is a very important detail. Now this gives us 2 Bucky cubes, one either side, but it leaves us a Plato in the center. In my earlier videos on DNA, I showed that this produced 2 Icosas in the dodeca. Now if we want to go to a bigger size, we're going to have to double this and go to size 6. So look, now we have 2 Platos, 2 Platos and 2 Platos. So let's bring the Bucky cubes in, and look, we have a Bucky in the center. I think we've got something good for DNA, because we've got pretty close to what we had with the size 3. And we can move dodecas by doubling the distance this time. And these moves will give us a string of Bucky and Plato cubes just the same in a beautiful order. Okay, let's go back to size 6 again, and I want to show you the vector. On the top I show a red and yellow vector. This is produced by the red and yellow cube. As you can see, they make up the vertices around the Yucatan rings. The red and yellow cube are both golden ratio to each other. And as I showed earlier, this geometry is essential for the helixes of the DNA. Okay, so I'll bring in the other 3 colored cubes, and then I show the other vectors of the dodeca. Now we'll go back to the size 5 Bucky cube arrangement. We can get rid of them Plato cubes now. Now I'm going to take the corner pieces of that cube away and give us a perfect cube octahedron. In my earlier videos I showed that you could morph a size 3 cube octahedron into an Icosa. Now I'm going to do the same with the size 5. And we'll take the corner pieces away and do it again. Notice that the blue squares are turning into a rhombic shape. These are perfect golden ratio. This comes from the 5 cube arrangement, but I'm sorry we can't get into all that at the moment. But we do need to focus on the yellow and purple sections that rotate around the corners of the cube. Now let's take a look at these yellow and purple pyramids that are part of the icosahedron. If you look at the top vertex, I'm giving you a perfect little size 1 5-sided saucer shape, and the geometry of the 5 yellow and purple little pyramids will give you one of these pentagon saucers. Now we'll take everything away and just leave one pyramid, and we'll show these 5 penta saucers again. All the colored triangles except the yellow belong to the octahedron family. I don't think these are really essential to show, because all the little yellow pieces will give us the vertex positions so that you could look at the molecular structures. And you can see on this one portion that we have pentagons and hexagons, and the pentagon and hexagon is used for DNA, no? Okay, let's show them saucers. Let's call them pentasaucers. These little saucers will give us an icosa in the center. This is the smallest icosa you can get. I'm going to give it a Latin name, Icosita. Now I'm going to add one more little saucer and change the icosa into a size 6 because I found this size useful. Now I'm going to bring in the vector colors that I use, and I've changed all the colors of the Icosita to the correct vector colors. Pretty colors and a Latin name. How posh can I get? We'll give the 5 saucers nice colors also. Okay, let's go back to the Icosita in the center on its own. Now we'll show a size 2 icosa outline. Now if we show another 12 of them pentasaucers, look what we have. We have a size 2 icosahedron. And if we add another 12 saucers, we get a size 3 icosahedron. Let's focus on them 12 saucers on the size 3 icosahedron. Now look at this. The 12 pentagon saucers form a nice soccer ball, or truncated icosahedron if you want to get posh. And this shows hexagons and pentagons, often shown in DNA. Notice that the 5 colored pentagons, they form 20 triangles, and the colors will match up with the vector system. Okay, we'll leave the soccer and go back to the icosa 3 again. And we'll just keep 3 saucers on the top and 3 saucers on the bottom. Now I'm showing 2 red and yellow pyramids. They're all tetra pieces combined together, and I show the hexagons on the top. And these colors will match up if we put an icosita in the center. Okay, and now I'll bring in the rest of them pyramids with all the correct colors to give us a size 3 icosa. And we'll go back to the size 6 icosa outline again. I've got something new to show you. In this part, I'm going to bring back the dodeca outline. Now we'll move a size 3 pentasaucer, and you can see that it fits perfectly between the size 3 and size 6 icosa. Now this makes a perfect rung for giving us bDNA. This is a little animation I put together. This took a little bit of time to figure out, but as you can see, the helix goes from one icosa to the next icosa and then the next icosa. It's always going forward, hooking one icosa to the next. Notice that one rung goes perfectly through the center of one icosa. The next rung joins one icosa over to the next icosa. I realize it's probably difficult to figure this out looking at the side view, but look at the top view. Now you can see how perfect that helix is. It's perfectly round. And now it's plain to see that the size 3 saucers, the vertex are meeting perfectly into the center of each of the 5-sided faces. 3 of these faces are facing upways and 3 of the faces are facing downways. That's what makes the vertices of the dodeca go in ratio to each other. Okay, something else. If I draw a yellow ring around the 6 saucers, which is the size 6 icosa, it will give us the diameter of the bDNA. And I'll make a red ring around the dodeca vertices. This will give us the aDNA diameter. The size 6 cube that I use is 600. I found by dividing 4.24 into the diameter, The results match the diameters that they show in research publications. So now we're on the diameter subject, let's take a look at the Z diameter. Let's bring a size 6 Icosa into the scene. Now I'm going to bring in a cyan ring, and it goes around the vertices of a size 6 saucer on this Icosa. I'll show a saucer ring half the size around the coloured size 3 Icosa. It will make it easier to figure out. It took me quite a while searching for this diameter, so we'll get to this later. Okay, so now I'm going to bring back the dodecas like I showed in my previous videos. And now you can see plainly that the vertices of the Icosa are sticking out a little bit in dead center of the dodeca faces. The helixes rotate at a 60 degrees difference between each of the vertices. And this size 6 DNA is exactly the same as what I showed in my previous videos. There'll be a 9-bend system, and this will all go with the 10-20 vector system I've showed a couple of years ago. I guess people don't go for non-chaos. Okay, this brings us to the end, covering the B DNA. And because these videos are getting a bit on the long side, I've decided to make another video for the A and the Z DNA. So this is Paul saying bye for now, and I hope you're going to take a look at my next video for the rest of the DNA.